Today we will start with unit number 3.2.4, that is wiring requirement. So wiring basically is needed in and not only in the solar PV system, in any electrical system to connect power supply and the load. Power supply here also we can include other components as well, means which are a part of the power system. So we can interconnect them. Okay, now we want to run a load, then we have to connect it or transfer the power through these wires. So the choice of wires, which include choice of material for wire. The first thing, material for wire. Another thing, diameter of wire. Okay, so that plays an important role. How we will discuss it. So the appropriate choice of wire is even more important in case of solar PV application. And why is it so? Because it is dealing both with AC current as well as DC current. Okay, we are considering our load to be AC here, household load. Okay, so our system is dealing with both AC and DC. So the appropriate choice of wiring is important. Why? Because this will reduce the electrical losses in the wire. Since solar PV power that is expensive, so it is important to minimize the power losses in wires as much as possible. The losses are less, then efficiency will be high, more energy we will be getting. Okay, overall, the economic value of the system that will also increase. Another importance is that this will help to avoid shock hazards and fire hazards in a PV system. Means from the safety point of view, the economical point of view, efficiency point of view, and safety point of view. Another importance is that this will help the system to perform better. Means overall performance that will be better, the quality that will be better. If all the components in the PV system are chosen sufficiently but appropriate wire is not available, the system's performance that will deteriorate. Okay, now considering an example, if a large current is flowing in a certain part of the PV system and wire chosen that is thin, diameter of that wire that is less, so the losses will increase. So here we take some basics like the Joule's law of heating. So H, the heat developed, that is equal to I square RT, square of the current into resistance into time. The resistance R, that is equal to rho L upon A. Rho is the resistivity, L is the length, and A is the wire cross section area. Okay, that is the thickness of the wire. So that is inversely proportional to the thickness. Resistance that is inversely proportional to the thickness. So that means if current is more, then heat will be more. But if we can reduce the resistance, I square RT, that is equal to the heat. If we can reduce the resistance, in that case, it will be less. The resistance is less, it means the power losses I square R. R, that is the resistance. The power losses that will also be less. Okay, so we can say our system, if it is having connected through a wire of a less diameter, less thickness, then heat will increase, losses will increase, and there is a chance of burning. Because of heat that will increase, it will burn insulations. Okay, so there may even be fire in the system and the whole system will stop working. And in the worst case, the entire PV system may be destroyed. So we have to take care of the wires as well as we take care of the other equipments which we have discussed in our previous chapters. So electrical wires are made up of metal because metals are most conducting. That's why we have selected it, and most suitable metals for conducting electricity may be silver, copper, aluminium. Now here, quality as well as price, both we have to consider. Silver price is high, we have to avoid. Copper and aluminium. Copper, the price is high, but resistance is less. In case of aluminium, the price is less, but the resistance is more as compared with copper. So this makes copper more suitable. Price are reasonable, but more than aluminium. Okay, so we prefer for copper. So generally wires are coated with any insulating material like polyvinyl chloride, PVC, nylon, polyester, so as to prevent shock hazards and energy loss through unwanted conduction and avoid short circuit between two wires running together. Yes, so okay, the covering, outer covering of the wire. Okay, now one more thing, wire. We have collected wires. We have bundled them together. These wires are there covered by some type of insulator, and we have bonded them, twisted them. Okay, then it becomes a cable. Okay, or wire cable. We call it as a wire cable. The wires are shown here in the diagram. So conductor surrounded by insulator, then two wires together, bundled together. Cable becomes like this, having these two wires. Okay, so different type of wires we can see here in the diagram. Two, maybe three, maybe one more. And the diameter or thickness of the wire, that is also different as per our requirement. Now considering voltage loss in wire, the voltage desirable to drive electricity in a wire, that is known as the voltage drop. Means there should be a potential difference. Some voltage at one point and another different voltage at another point. So there is a potential difference, then the current will flow. It is important to choose appropriate conductor with low resistance to minimize voltage loss in DC wires. V is equal to IR. Okay, so R is there. R is more. V will be more, means potential. Okay, voltage, that more voltage will drop there if the resistance is more. So wires with low resistance are of large diameter. Okay, but larger diameter wires need more metal, and correspondingly the cost also increases. So cost of the system will increase. That will increase the cost of the energy per unit. That is also not desirable. So we have to make a proper balance. We have to select the wire which is most suitable for our PV system. To avoid greater voltage loss, the wiring rules are listed as the length of wire should be as short as possible as per the required purpose. Need not take a very long wire because the resistance will be more in that case. The losses will be more, voltage loss that will increase. So the voltage drop in should not exceed 0.5 volt when we are operating in 12 volt system. And it should not increase 1 volt if we are operating in 24 volt system. The next point, a wire less than 2.5 mm square in length should not be used in PV system wiring. Well, here it is written length, but in square, that should be the area of cross section, means the thickness, 2.5 mm square. Okay, now type of wire. So it could be single stranded. The first diagram, that is single stranded. Another one, multi-stranded. So many strands are there. In each wire, multi-strands. The next is single core. Core, check the internal conductor there. Another one is multi-core, the fourth case. The difference that is evident in the diagrams here. From this, we can differentiate between these different type of cables. Now, solar cable. A cable utilized for interconnection of solar panel or other electrical components in the generation of photovoltaic power. We call it as a solar cable. The features of a solar cable are, it is designed as ultraviolet and weather resistant because it has to be in the sun, in the outer weather. The harsh conditions are there. So it is to be designed so as to tolerate that outside condition. So last temperature, second point, it is laid outside and used between large temperature range. In the sun there is a huge temperature variation, summer to winter, every time it has to stay outside the house. So it has to face that temperature range as well. The maximum DC voltage permissible at 1.8 kV for single core cables. Okay, here we can decide it. More is that, then we need multi-core cable. Okay, then temperature of approximately -40 to 90 degrees Celsius. Okay, that usually we are having in our locations. So should have a double insulation for protection against ground fault and short circuit. Okay, double protection should be there. Okay, insulation, proper insulation should be maintained. No short circuit, no ground connection. Okay, then no ground fault. Here it is not about earthing. Means a leakage of current to ground. That should be minimized. If wire is not properly insulated, then there will be leakage to ground. Okay, don't confuse it with earthing. Okay, next thing, the cables cut away needs to be appropriate so that 1% loss during economical operation is restricted. Okay, now MC4 cable. Okay, so this is the type. So male and female connecting at each end as shown in the diagram. So length, different length is available as per our requirement, 8 feet to 100 feet. So here in the diagram it is shown. So we can just connect male and female part on the top. Okay, so the use of an extension cable, that is not viable because the distance traveled by the wire in a solar panel setup of a house or a cabin is normally very long. So in such cases, panels are connected to a combiner box with the help of an extension cable. The combiner box, we are having one more component here. So this approach allows the use of cheaper wiring in electrical conduit to cater to long distance, and this reduces the cost. Okay, now solar cable connectors. So in the image here it is shown, male and female connector, and different type of connectors. They are shown in this table. Okay, so here a junction box that is used on the solar panel at the back, and at that junction box the wires are connected. So the recent PV modules have been added with MC connectors that appear from the junction box. So MC connectors, they are there in the junction box, and from there we connect our cables to the solar panel. So the MC connectors are weatherproof, safe and reliable. First one, solar line 1. The image shown there. The common connector on modules. It is a earlier version, 1990. It was famous. Currently, it is used but not much. So rubber end of each connector fit the ridges. It is essential that no gap exists for good connection. Yes, gap is there. Chances of leakage, sparking. So it is abbreviated as MC1 or MC3. Next is solar line 2. It is built into modules from mid 2000. So they are commonly being used today, just as we saw in the previous section. So rigid plastic and on being engaged and it clicks together. So as per 2008 National Electric Code, connectors that lock and click must be used when PV modules are installed in accessible location. The installer has an option of attaching an optional piece of the solar line 2 connector which provide a provision to lock. Okay, a special tool is required to unlock connectors. Easily means we cannot unlock it. That is also from the safety purpose, reliability purpose. So it is abbreviated as MC2, MC2L. Okay, L is for locking, and MC4 for 4 mm connector. Now coming to the size of wire. So now more volts are needed to push a certain amount of ampere. Ampere, that is current. Means for more voltage, we need for more current across a wire in a with less diameter. Okay, so diameter here, white matters, something similar which we had just discussed some time ago. Okay, so more panels and batteries should be installed to get a higher voltage, which includes extra cost. So in large diameter wires, the voltage required to drive electricity through wire is low, whereas the wire's cost is high. Okay, diameter is more, so more metal is needed, and correspondingly the cost will increase. Okay, but resistance is less. So voltage required, that will be less as compared with a thin wire. The thin wire is there, more voltage we need. So we need to install more panels and batteries. Okay, whereas in case we are using a large, more thick wire having larger diameter, then voltage required will be less, means less panel. Okay, but the cost of wiring, that will increase. So the best wire size will compensate the cost of a large wire with a low voltage and the extra panel cost from smaller wires that are relatively cheaper. So we have to make a balance. So more voltage is required to push 13 ampere through a longer wire. Okay, thickness we have discussed, now length. So more is the length, the more voltage we need. So similarly, we need more panels, batteries, so more cost. So short wires should be selected, means the shortest possible length of the wire that should be selected. So steps to find the correct size of the wire. So estimate the appliance rating, similar the load calculation. So draw a rough estimate of the distance between battery and appliance required by the wire to cover. So the distance travel. Okay, then allow extra length of wire to be placed around windows or doors or place it in switches. Okay, something for the extra length, maybe for the provision we are taking. Okay, the watt or ampere rating is usually shown on the label. Although sometimes it can only be found on specification sheets packed with the appliance. With the appliance means the specification, power, current that is specified about its rating. The ampere used by appliance can also be measured while it is in use with an ammeter. Okay, using ammeter also we can determine the current.